Lesson: AI model monitoring and maintenance for security. Artificial intelligence has transformed industries with its ability to process vast amounts of data, learn autonomously, and make complex decisions. However, the implementation of AI systems, particularly in security contexts, necessitates diligent monitoring and maintenance to protect against vulnerabilities that could be exploited by malicious actors. AI model monitoring and maintenance for security is an essential component of AI system management, ensuring that models remain robust, accurate, and secure. One of the primary challenges in AI model monitoring is the dynamic nature of threats. Adversaries constantly evolve their tactics, necessitating continuous vigilance. AI systems are susceptible to various attacks, such as adversarial attacks, model inversion, and data poisoning. Adversarial attacks involve inputting subtly altered data into a model to manipulate its output. For instance, an adversarial image might appear benign to a human but cause a computer vision system to misclassify it, potentially leading to security breaches. Model inversion attacks aim to extract sensitive information from a model, while data poisoning involves injecting malicious data during training to corrupt the model's learning process. To counter these threats, organizations can leverage practical tools and frameworks for AI model monitoring. One such tool is IBM's AI OpenScale, which provides capabilities for monitoring AI models' fairness, explainability, and robustness. AI OpenScale can automatically detect drifts in model behavior, an essential feature for identifying when a model begins to deviate from expected performance due to changes in data patterns. By integrating AI OpenScale, professionals can maintain a continuous feedback loop, ensuring that their models adapt to new threats and data landscapes. Another effective strategy is the implementation of adversarial training, a process where models are exposed to adversarial examples during training to enhance their resilience. This approach has been shown to improve models' robustness against adversarial attacks significantly. A study by Madri et al. Demonstrated that adversarial training could increase a model's resistance to adversarial perturbations, providing a practical solution for maintaining security in AI systems. Monitoring AI models also involves tracking their performance metrics over time. Tools like TensorBoard, part of the TensorFlow ecosystem, provide visualizations of model performance, allowing for real-time analysis of metrics such as accuracy, precision, recall, and F1 score. By using TensorBoard, professionals can detect anomalies in model performance, indicating potential security issues or the need for model retraining. This proactive monitoring helps in identifying and mitigating risks before they can be exploited. In addition to technical tools, organizations must establish governance frameworks for AI model monitoring and maintenance. The NIST AI Risk Management Framework is one such framework that provides guidelines for managing risks associated with AI systems. It emphasizes the importance of continuous monitoring, incident response planning, and regular audits to ensure AI systems' security and compliance. By adopting such frameworks, organizations can align their AI practices with industry standards, enhancing the security and reliability of their AI models. Case studies further illustrate the importance of AI model monitoring and maintenance. For instance, a financial institution using AI for fraud detection experienced a significant decrease in model accuracy due to changes in transaction patterns during the COVID-19 pandemic. By implementing continuous monitoring and retraining strategies, the institution was able to adapt its models to the new data patterns, restoring their accuracy and effectiveness in detecting fraudulent activities. This example underscores the need for dynamic monitoring and maintenance practices in AI systems. The integration of security into AI model development and deployment also involves addressing ethical considerations. Ensuring that AI systems are free from biases and treat all users fairly is crucial for maintaining trust. Bias monitoring tools, such as fairness indicators, can help identify and mitigate biases in AI models, contributing to more secure and ethical AI systems. By incorporating these tools into their monitoring processes, organizations can ensure that their AI models are both secure and equitable. AI model monitoring and maintenance for security require a multidisciplinary approach, combining technical tools, governance frameworks, and ethical considerations. The dynamic nature of threats necessitates continuous vigilance and adaptation, leveraging tools like IBM's AI OpenScale, TensorBoard, and adversarial training to enhance model resilience. Governance frameworks like the NIST AI Risk Management Framework provide a structured approach to managing AI risks, while case studies and ethical considerations highlight the real-world impact and importance of these practices. By implementing these strategies, professionals can effectively secure their AI systems, ensuring they remain robust, accurate, and trustworthy in the face of evolving threats.